but it's very simple. So we start today by doing the things that we are used to. So let's say, for example, we had to expand something like this. A plus b to the power of 2. This is very simple. We are used to expanding these simple functions, and all we have to do is, remember this, a plus b by a plus b squared, right? So we recall that a plus b squared simply means a plus b by a plus b. And we can expand this out. A by a is a squared. A by b is plus ab plus b by a is plus ab. B by b is b squared. Right? So we have a squared plus ab is 2ab plus b squared. Okay? So this is a simple form of binomial theorem where it gives us this simple function and it's expanded out in this form. Right? So we know this. So we can write it here, a squared plus 2ab plus b squared. Right? So that's one that we have. Next, let's try to do a plus b all cubed. Lost my duster there for a minute. Right, so simple. A plus b cubed will simply be a plus b plus a plus b. Very good. Let's see how it actually looks. So this is 1. Let's say now we had to do a plus b cubed. What will this be? This will be a plus b by a plus b by a plus b. Good? But, and we know this already. We know a plus b, which is this, which is this. So we could simply write, okay, well, a squared plus 2ab plus b squared, which will replace this and multiplying it by a plus b. That's okay? Right? All this builds up to what binomial theorem really is. It's a simple theorem that we could use to get these expansions. Of course. Okay? So a by a squared is a cubed. A by 2ab is 2a squared b. A by b squared is a b squared. Do it again. B by a squared is a squared b. B by 2ab is 2ab squared plus b cubed. Okay? So simplify it now. We'll end up with a cubed. 2a squared b plus 1a squared b is 3a squared b. ab squared plus a squared, 2a squared b is 3ab squared plus b cubed. Simple. So a plus b cubed is this. Right? This is simple expansion. Let's see what we have now. We have a cubed plus 3a squared b plus 3ab squared plus b cubed. Good? Okay. So you're taking this off. Right? So good. So we have a plus b squared, a plus b all cubed. So if we look, there's a pattern developing. So let's just say now I wanted to get this. Let's say I wanted to get a plus b to the power of n. Look at the patterns, look at the similarities. The similarity says when this was 2, a is squared, when this is 3, a is cubed. So make a guess, if this is n, then this is possibly a to the n. Okay? Right. Next, these numbers here, so these coefficients here in front, those numbers are found by using a new function, which I will show in a little while. Right? So, in fact, I'll introduce it now. That function is called NCR. Right? Return NCR. It represents the number of elements and how many of those elements we are choosing. This will be done in a further class. Okay, so let's just continue here. How do I get a 3 and a 2? Well, it will be n, whatever n is, C1. Okay. Here, this value was 3, this value is 2. Just for convenience sake, this value is 1, and the value here for A that's missing is 0. So it simply means, like a similar pattern here, 2, 1, 0. So it means that A is going from its power here, 2, to something smaller, until it reaches 0. So what are we going to write here? We're going to write A, this is 1 less than this, by n minus 1. By B, power here is 1. If you look at B, B follows the same pattern. B was 0 here, then B goes to 1 here, then B goes to 2 there. So this is B to the power of 1 plus, you follow the same pattern, n C2 by A. This is 1 less again, so you're minus, instead of minusing 1, we minus 2. This is 1 more. So we write 1 more, which is squared. Okay? And this will continue until we reach the last term, n, Cn, A to the n minus n, B to the n. So if we look at this carefully, this and this is really the same thing. If I were to say, okay, well, let n equal to 3, I'll get back this exact function. Let's see. Let's just make sure we know what's going on. Okay? So let's take an example. A plus B to the power of 3. So n is 3 by 3 C1. And I'm going to show you how to work this out 2 ways in a little while. A to the 3 minus 1, B to the 1, plus 3 C2, A to the 3 minus 2, B 2, plus, these two must be the same, so after 3, 2, and the value here is 3, then obviously it's 3, 3, by A to the 3 minus 3, B to the 3. So this is really A cubed, 3C1 is 3, by A squared, by B, 3C2 is 3, by A, B squared, plus 3C3 is 1, you're able to give us 1, A to the 0, B cubed. And if you look at this and compare it to this, it's the same function. So binomial theorem allows us to expand functions like this, where n could be from any power 2 to any large value. Okay? So this is binomial theorem. This is the example here. And this here represents the actual theorem itself. Right? The good thing is that this is something that we don't really have to cram off, but I wanted to show you where it comes from. This actual function here is given in your question booklets. So one less thing to remember, but make sure you understand how it works. Good. So let's spend some time now on this NCR. Right? Let's spend some time on this. Okay? So we understand how the expansion comes up. A plus B to the power of n is equal to e to the n plus mc1, I know about this now, by a to the n minus 1, b to the 1, plus mc2, a to the n minus 2, b to the 2, plus mcn, a to the n minus n, b to the n. Or we could just leave this out. Or we could just leave it out as you would see in some examples. Right? Okay. So the next thing I would like you to note is what is the term? Like if I wanted to find any single term, the general term is simply NCR by e to the n minus r, b to the r. if you want to define this second term here, it will be 1 and minus 1, 1, and so on and so on. Right? Note that this could be considered to be the rth plus 1 term. Okay?